Hi, Sportster Paul here. We're going to do the second impression of BobCAD CAM. Makes G-code for your milling machine. I've got the part loaded up. Let's just get right to it. Up here in SolidWorks. I've turned the add-on in tools. You got to go way down here because of this goofy thing. You'll barely be able to see it. Add-ins all the way down here. I put Mastercam in the other day. BobCAD. I saved it as a -2 part now, BobCAD 2. So both of these, the way I start right here before I change the name, and when we're done, I'll have that up on the web page that I write as part of this video. So you can see the toolpaths. We did the perimeter. You can see these straight toolpaths here. That's the facing. All pretty standard stuff. You can go in. This is the tab. This is for art stuff. I'm not going to use this as posting. We're not going to post. They only do 5 lines of post in the demo program. And I should note, in this demo program, if you download this file and try to open it in your paid for BobCAD, it won't work because that's the condition of the demo. They don't want you buying one working program and 50 demos to do, a whole company's work. That's all cool stuff. I don't blame them a bit. So here, this little thing, you say hide or show the toolpaths. Now you can see the part. You can go individually in the tree, and instead of hide, they call it blank unblank. I guess before people use the word hide, they use blank. This is lit up because the feature is lit up. Where's the next one I did? Facing. So there's the facing feature. This is the perimeter we did. So we're going to start with a little housekeeping. I'm going to rename this to top setup. Rename feature 2-axis. It really helps keep track of stuff. Perimeter. Did I spell that right? Parameter. All right. So you can get that there. So facing perimeter. Some of the things on the perimeter, one of the things I didn't like, let's unblank it. Unblank it. You can see the end mill is coming down and plunging into the corner of the stock. Well, let's show you the stock. Unblank the stock. So there's the stock, right? The green box. So I just don't feel good plunging an end mill, even though there's plunge roughing and all that. Since we got open air, I thought it's best to come in from the side. It's not super straightforward, but see, I'm used to their simulator that uses all, different way to pan, different way to do everything. So what do? Perimeter. I'm getting warmed up as we go here. It's both roughing, well, no, the finish will be okay because that's just one pass. I think it'll be all right. But roughing leads. Vertical lead means it's plunging, right angle, 1/4 inch. Well, let's make it 1/2 inch just in case. And you can watch, as a matter of fact, right here in the corner, see where it's coming down, right on top of the stock. When we say compute, that should jump out. Sure enough. So now, when we simulate, you'll see it coming in from further out. I also found out why the simulator, I figured it worked different than SolidWorks because, the panning and zooming and all of that business, just because they use their code base for the standalone BobCAD. Well, it's even more understandable. It's not their simulator. They buy the simulator. File, info, is this it? Options, somewhere in here, it says about. The simulator, BobCAD buys from this outfit called ModuleWorks. And here's all their information, which is why it's different. In a way, it's a way to, get a lot of performance and rather than trying to develop the code yourself. So no crime there, but I don't like it in that it's really not using the SolidWorks animations and whatnot to do the simulation. It also doesn't do very well. Well, let's run it real quick. We'll just say fast forward. Bam, it'll do it real quick. So then you say verification, gouge and excess report, show excesses, and it gives you things that, since it's not color coded like VisualMill or like SolidWorks CAM by CAMWorks. See, I keep using the wrong zoom buttons. I'm used to SolidWorks. It's not super clear. I think this is a big one, 3/4 inch, because there's a big pocket under here. It's like, well, yeah, but I want to know what's different than my design intent. And that's easy to see if they have a compare button and it just color codes the part, what's undercut, what's gouged, what's overcut, what's stock left. So now we kind of understand the simulator. I have to admit, I got through my practice sessions. I got through this whole part. And when I was done, the only, not mistakes, but the only report that came out was gouges, no more excess at all. But it made sense because it was where the tapped holes is. And you run a 1/4-inch tap through a hole that's defined as 0.201, the tap drill size, not the tap size, the outside of the tap. That happened in all of them. In SolidWorks CAM, it showed it in red. VisualMill didn't even bother. They left them gray, saying, well, it's not going to be right, but it's not supposed to be right because it's a threaded hole. The other thing, was it File, Options, Verification Properties? No, Graphics Background, Customize. Somewhere on here it shows the accuracy of this thing is 0.008 of an inch. And we were doing 5/10,000ths in the other simulators. So yeah, everything will be green, but you'll see, it'll be a few shows before we get to doing some of the 3D-ish stuff. But it did a little gouge and it just passed because it wasn't an 8,000 deeps gouge. So I wish I could find that for you real quick, but we'll play around. It'll be in here somewhere where it shows. And I tried, I went in options. It's like, tighten it up. Give me an accurate simulation. I couldn't find a way to get it tighter than 0.008. Maybe as I keep practicing off camera, we'll learn that. Let's close that and start moving along. We got our top setup. We got our perimeter. Now you can just individually blank that. Now let's do the pocket. This top pocket. It's been about the same. You say, insert a mill 2-axis, select the geometry. You can go here and right-click in SolidWorks, say select tangency. This is a SolidWorks function. Same down here. Select tangency. I wish you would do the whole thing, but it gets you closer. You do here and here, then you do here and here. Then after a lot of grief, you realize there's a tiny little one down here. Okay, now you're ready. You selected the geometry. It always wants to rough and finish, but what it's going to get wrong, how do I show you folks? I'll move this off screen. And you can't see, there's another problem with the dialog box open. You can't move stuff around. It's going to get the depths wrong. It takes the depth as that flat spot where the slopes go and the flat place. It's like, oh, you must only want to go that deep, which is fine. I mean, it can't understand your intent. Software tries to do your thinking with this automatic feature recognition, but it can't. It can do your work. So pick top. We'll just go through it just in case. Pick top, well, we know for a fact the pocket starts way up here. I just like to pick a point, say okay. Now pick bottom instead of 0.3263. We know we want to go to the top of this little island here. So we go there, that's picked. Now notice it's 625, like all the other programs. Rough, it is 1/4-inch flat mill long. We want that. Finish my screen. You see now it uses a standard flat mill. And I don't think the flutes are long enough in the standard one to go all the way down. So we'll just do the simple thing. What's going on? The 2-flute version. See, there's a 4-flute that comes in the crib and you just change it. It creates a new tool and say, okay. Now just for grins, let's see if we can delete this one. Delete tools. Okay, so somewhere I'm using this 4-flute. Maybe in this very same operation. I just didn't notice. Yes, see, 4-flute. Go to the 2-flute one, because that's going to affect your feeds and speeds and your chip loads, right? It's important to be accurate. Always be accurate. Now let's try again. Take this 4-flute and delete it. Delete. So it's currently used. Okay, must be somewhere else I left it, 4-flute. We'll go hunt that down later off camera and fix that. So let's just try. Well, I know there's going to be a lot of things wrong. This is that 50-50 shot. Is it going to cut the outside of that geometry or the inside? Because it'll hog through your model. One of the things I don't like. Multiple steps. This is one of the things. I want to go 125 deep. 125. Then you go here. It says, oh, it's going to take 5 cuts to do that. So even depths. Same thing with the finish pass. Multiple steps. 125. I find if you go click, click, then it down this grayed out box. It says 5. That's all. 0 allowance on here. I don't think there's a whole bunch of other stuff. Say compute. So it's got the allowance correct, but it doesn't. When I say rough, usually a lot of programs say, oh, if you're roughing, we're going to cut all this stuff in the middle out. That's a pocket. Because this one, it doesn't let you up front say, I want to do a pocket. Well, all it knows is geometry. So it thinks maybe you want to do a profile. This could be a perimeter, you know. So that's one of the things. Okay, housekeeping time. This is the deep pocket. Bang. Let's do a save. They let you save things. Bless their heart. Can't open it in a paid-for version, but I was just warning you. You can't load the toolpaths into a paid-for version. That's all cool stuff. I don't blame them. Okay, I guess you just go edit again. And it is in rough. It's where you don't think it's going to be. See, because it's all this space. And they're trying to be, they're not trying to, you know, since they do overwhelm you with all these dialog boxes, they're trying to make it less serious. But it doesn't reveal what's going on as much when you say side roughing. Oh, yeah, that's kind of what I want, except flip it around. You know, but I want to hog a bunch of stuff out. You'd say stock remaining. Doesn't work. I've tried it. I've tried it with this. I don't know. I'm probably doing something wrong. Say step over, because the step over is 0. It still does. You know, it just will do this one tool path. So I go the same 1/8 inch. I got a pretty flimsy mill, Avid benchtop row, compared to a Kitamura, but very stiff. It does aluminum. One fellow I talked to does steel. So there's a step over. Number of oh, this will be wrong too. You got to give it tedious back and forth. One of the problems I have with this program. Hey, you do the computation. You know how many step overs to fill that pocket? Well, no, you got to say, I think 6 works. The number 6 after a lot of grief. Yeah, so 6 gets you down here so it doesn't leave a little post in the middle and in the middle. So if this is like before, let's save it. Oh, I love that they let you save. Give somebody a cookie, whoever did that for us. Go do a simulation. I think we're about ready. I wish that you had the word simulate the way VisualMill does. You can go by ops. This is, you know, you get to simulate. Okay, did the decking, did that. I'm kind of surprised. Oh, this'll. It's juggled because the tools are rough and finish tools. It's juggled the order of the tools. Did this to me before. Milling job. Machining order comes here. I don't understand why. Did I put it in the wrong spot? I did. Deep pocket is after the perimeter. Why is decided? This might be because of the tool selection. It doesn't always act like this, right? This is one of those mysteries. Now, do this deep pocket. Do this afterwards. And then this deep pocket I also want to do afterwards. I want to do the rough and finish because it's the same end mill, right? If I was changing from a hob mill to a plain one, you could understand all this. So do the perimeter, rough finish. Good when you saw this, so you know it's there. Although I suspect that 1/4 flute tool I got floating around here somewhere is doing that to us. Go back, let's do a save. Oh, thank you so much, BobCAD. Here, let's go to their simulator. Think. Next stop. Now it'll do the perimeter if life is good. I think now it'll do the finish of the perimeter. You'll see it change color a little. Yeah. And now, and what I like to do is turn off the toolpaths. And now it'll run and do its thing. Oops, not if you don't click it the right way. It had a crash. This happened in practice, so I knew that it was coming. And this, I thought I'd show you the frustrations you're going to get. And don't panic. You can fix everything, right? Here. Okay, it's crashing. It's not that table crash we showed you last episode where the part's buried inside the table. This is a legitimate toolpath crash. It's happening in the roughing. So here, rough. When you do edit and highlight the rough instead of the whole feature, all it does is bring you here into the same batch of wizard dialog boxes. And the wizard doesn't thrill me. You know, I don't know. There's a VisualMill was the interface I liked best. So what was it? Wasn't leads. Was it lead in, lead out? No, it was something about clearances. You know, how high, side allowance, bottom allowance, profile rough, machining. Was it the feature way up here? Yeah, I think it was up here. All I had to do, let's see if it works again. You know, nothing works twice in software, even though it's supposed to be. I think all I did was this, recompute them, File save them, because yeah, this does crash, but not nearly as bad as VisualMill crashes. So where were we? Simulate. And let's just, oh, you got to be careful. I think it'll fast forward over a crash. So, you know, at one time you got to run it, because I'm pretty sure that happened to me. So let's do next stop, next stop, next stop, and now do run. See, now it's happy. It astonishes me that it would make that mistake, but then it astonished me when SolidWorks CAM plowed a tool through the side of the part. I think this all goes back to when you could have a chamfer. You know, the chamfer wouldn't be drawn in SolidWorks because we all had 386 computers. So then you'd let your machining program, you'd let your CAM whack a chamfer, even though there's a model there, you cut through the model to put the chamfer on. So the programmers just have this attitude, oh, you can cut through the model. That's no big deal. I wish they'd have more of a, hey, you know, this operation is going to carve up your part. Do you really want that? Here's another nice thing about BobCAD. They have a nice responsive way you can kind of speed things up. Go a little bit faster. I don't know if visibility works. Oh, wow, it works while you're simulating. Thank you, MachineWorks, whatever works it was, it does it. Done. Not too shabby, as my dad used to say. Okay, so do another, I don't know why I'm saving again, getting paranoid. All right, so that was the deep pocket. Now, we're going to blanket. Now, for SolidWorks CAM, for VisualMill, they both had this problem where it would, if you just use the bottom face as a contour to mill, you know, as a pocket, tell it it's a pocket, it gets in trouble here because it has to do this arc. It goes around. It doesn't know to bomb straight through and keep this surface matching up here. Same has a problem down here. Even though this gets drilled out with a drill from underneath, it would leave a little bit of stock here. Now, I didn't see that in this program. As a matter of fact, if I just say, take this and do your thing, it actually looks pretty good. Let's try that. You know, I think it's worth exploring. Because this would be great if this thing is actually smart enough to get away with this. And we'll see what happens. So we're going to do D-pocket, insert, mill 2-axis, select the geometry. We'll select this bottom face. So now it's got, you know, it's cutting around this island. It's doing all its thing. We'll say OK. We'll hope that left-right, that so confusing thing in system compensation, which means which side of that line you cut on. I think left puts it on the right. Once they did it wrong and it carved the whole part away. We're doing the bottom. That means parameters. We want to do it in 2-ax. Depth of cut. Oh, that's wrong. Wait a minute. Let's go to feature. Pick top. Oh, it thinks it's going, I don't know where it thinks it's going from. Pick the top. Here. Okay. Now it thinks it's going 3/4 of an inch. I don't know. That's all the way down. Pick bottom or all the way up. This is the other thing. VisualMill lets you do this kind of stuff too. I love it. 125. It's a shame that I'm so familiar with this part. I kind of, and so rehearsed this so many times. I know what to expect, and I knew that was going to be a problem. But that's why the simulator is so important. Going back and forth and back and forth and looking at the toolpaths. And what's this thing doing to us? So let's see. Compute. Where were we? We were doing patterns? No, this is good. Oh no, we got it. We do in rough because it won't do the same problem. See, and to me, this is just a little clumsy. It works though, right? It's not crashing a lot. The dialog boxes aren't changing, so we know to do that. What was the other one? Parameters. We want to go here. You're going to do it in 2-ax. Perfect. You know, it's going to take two 625s. And then same problem here. You don't have to fill the inside in with this business. Well, they don't even give you the choice in a finish. So parameters here, multiple, say compute. Something's wrong. Look at this mess. It always goes good in rehearsal. All right, let's do first. I like to do housekeeping when adversity faces me. What is this? This is the shallow pocket, bang, and we don't need to see all that crap. We just need to do an edit, and we need to figure out what we did wrong. The pattern was wrong. Oh, I said stock remaining. Duh. Compute. Still didn't do it right. Edit. Got the top of the feature right. All that stuff works out. Oh wait, we might have a 1/2 inch end mill. We got the 4-flute, so that's one problem we found. He just bothers me. This thing doesn't seem to learn. There's the 2-flute. Tool crib. There's the 2-flute. So we're doing that the same, and it is 1/4 inch, right? Sometimes it'll stick in a 1/2 inch. I'm confused. It's got a small side allowance. That's all fine. The depth of cut. That's all fine. It should be right here. Roughing. Step over. Oh, funny. I guess when I changed this, I didn't notice that this number changed. It's always fun to watch the videos and see how it screws you up. Now say compute. Now it looks kind of like we expect. And you always watch real close. All these purple lines, because those are traverses, and if you got a post sticking up somewhere, you know. One interesting thing is when it selected the face, it knew enough. Some programs want to cut this out. It'll look at the face and see that there's a hole here, and it'll leave a post right here sticking up because you didn't say to cut it. BobCAD, maybe it's a bad feature, maybe it's a good. It just happened to act the way I needed it to act. But look what it does here. See, it just stops the toolpath. Stops this toolpath. And it's going to leave meat here. We'll go look at this. I didn't explore it enough. I'm doing the simulator zoom and pan. That's why I keep being so goofy. Same thing over here where you think it just stops the toolpath. So it's going to leave little, what do you call it, a little cusp or a little fillet there. I don't know. We'll figure out what's going on later. File. But this is the first part where I didn't have to draw a sketch. And I think I'll end up having to draw a sketch. If the simulator was better, we'd know for sure. Save. Yes, we understand your limitations. You're being very fair. Once again, I prefer the BobCAD, that company's pan and zoom to SolidWorks, but you can't change SolidWorks to act like the simulator. All right. Shallow pocket, all this is cool. I think I did a save already. Let's do next stop, next stop, next stop, next stop. Now it should do the finish. See, it got a little bigger. We'll turn off those tool paths. Now this one, okay, this one's index finger to do what middle finger does. And what's a good way to look at it? Maybe right from here. I want to see it doing this. I want to see both, actually. I want to see this hole here, but for now, let's just do run. Same problem. Stock collision. No, don't. When you find a problem, fix it. Otherwise, you'll forget. Oh, there's something to experiment with. Let's just go to end. Fast forward. Will it call that same problem out? No. Danger Will Robinson, right? You don't want to see the pretty little animation? Well, that also short circuits and ignores the crash we had. Danger, danger, shallow pocket. Edit, see why I rename stuff? What did we do? We did the rapid. Let's see if we can just go up that slight bit more. I'm doing something wrong. That's why this is crashing. There's something I'm doing. I don't think this is anything buggy about the program. This is too basic of a thing. This is a simple prismatic part. File save. Thank you, BobCAD. Thank you, thank you, thank you. File save. Simulator. Next stop, next stop, next stop, next stop, next stop. Run. Tool flute. Oh, I think maybe I do know. No. Come on. Oh, it's so frustrating having the navigation work completely different between the simulator. That's why I think, see what they've done? They've plunged down. They put the center of the tool somewhere on the tool path, so they're crashing down there. Now we understand the problem a little better. Should have probably looked carefully first. That is, this might be because I asked for too many. It should look like the upper tool path. What did I do different? Edit. Patterns. Let's do 5 and see if it computes it different. No. As long as it has this one here, I think it's going to crash. Although it shouldn't. Although, see, the stock isn't, well, no, see, that stops before this line. Is the rest of the thing machined? No, I don't think. See, it's going to leave an island here. Okay. This is the joys I've been having. Where were we? Rough. Oops. Patterns. I think we got to do 6. It's the only way. And like I say, why this acts different? Step over, zigzag. I don't care about that. System compensation, compute. See, as long as this little line here, this toolpath, extends there, and this is some kind of overflow where it's reflected the toolpath, and now it's, well, yeah, you wanted 6. You know, since their stock removal thing I can't get to work. Edit. Pattern. Stock remaining. Oh, I said finish, I meant to say. Well, it changed it a little. That's interesting that it didn't crash. But it's still going to bomb here. And like always, in rehearsals, the 7 times I did this, I didn't have this. Actually, it happened once, and somehow I worked my way out of it. And darned if I can remember how. Rapid plane, that's not going to fix anything. It's this pattern. Stock remaining, 0.7. See, it thinks it's got to go all the way up. This isn't right. Well, all I can say is let's go down to 5, which isn't going to be right. Say finish. Oops, forgot to do it correctly. Compute toolpaths. It shortened it. Save it again. Save. Coming up on our half hour. Ridiculous. 2 pockets. Simulator. Next stop, next stop, next stop, next stop, next stop. Okay, now run. Okay, we missed it, but I think it's going to leave a post in the middle. Let's see. You never know. But it also might break off a tool, right? Because if that post is there, visibility, nothing works the same. It kind of looks okay. So I think you can see what happens because it's a funny shape. See, Dave Rui, my genius buddy, mechanical engineer, industrial designer, machinist, does it all, Renaissance man. He knew this kind of part. This part was made to trip up CAM systems, but more the automatic feature recognition. The problem I'm having, and I am probably doing something wrong, let's not blame the program just yet, you know, I don't know what I'm doing, I'm just learning this stuff. You can kind of see when you tell it, hey, I want 6 passes, it starts folding things over on itself, saying, well, you wanted 6, I want to give you 6 no matter what I have to do. And that's what generated that toolpath that got into the edge. Apparently 5 is enough, because it looks like it's doing, you know, it's leaving, it's cutting all the material out in the center part. Why it's a different shape, I don't know, than the deeper pocket, I don't know. Plunging, all that stuff, I guess we're okay. Visibility, hide the toolpaths, go back, do this verification business, say gouge and excess. It thinks for a while, show excesses, see, and now it's got this stuff. See, it does funny things too, like it leaves little color changes here and here and here, and what is that? I think they're non-existent, you know, it's just, you know, a rounding error in the math where, okay, we think we're on that surface. Well, it might be that surface, and that kind of stuff changes. This excess material, see, once again, I would expect it to be 4/10 of an inch minus the 20 thousandths extra deep we went. And this is talking about the stock we left on the bottom that's holding the part in the vise. This one is the hole. Oh, we wanted to look at that. See, this is how it ended up. And I got to tell you, this is actually going to succeed. If we drill from underneath, I think this will actually be an accurate part. So that's a BobCAD major plus, that it let us get away without having to draw a sketch and draw a straight line here for the toolpaths. Unlike the other programs that made that arc follow, this one just kind of gave up, and it's not following the arc of the model. That's astonishing to me that it's smart enough to do this. Now the problem is, okay, here's going to be the problem. When you drill from underneath, you're still going to leave this. And you say, oh, well, that's not a big thing. Look, machining is precision, thousandths of an inch. So to a machinist, or when you're evaluating software, you want it to make things exact. Not, well, that's just a little. We'll show you the gouge we get. That's just a little gouge. No, it's not the print, right? And it's very apparent. It's an appearance issue that when you show it to your boss or the customer or your mother, it's like, well, what's that little gouge there? So it looks like we're going to have to do the same kludge with the other programs, which is draw a sketch. Show you real quick. Matter of fact, we might get away with this quick. I'm going to go a little long. It's already 30 minutes. Let's go into SolidWorks. Oh, I think I crashed it. Are we still in the simulator? No. Let's go blank toolpaths. Blank toolpath. Let's blank the stock. Okay, let's go here. Now we're doing what we want. Okay, pick that face. Say, make a sketch out of it. Sketch plane. That selects the plane. But in addition, now that you've got it selected, you go to the, what I love the most, convert entities. And it's smart enough it doesn't throw that hole up, but it throws a whole perimeter and made a sketch out of it. Then you got to go here, delete, delete, and delete. And you want here, hold the control key down, hold here, our favorite convert again. And now you've paved over that hole, so this upper part, no matter how deep this under hole, the hole coming, the 1/4 coming from, you're going to have good surface like where it left that little fillet. So this one actually might be getting away with it in BobCAD, bless their hearts. That's really cool. They knew to stop the tool pass. This one you just go and extend the line. And one of the things I love, my old cracked 2005 SolidWorks, I've been paying legal for several years now. The newer versions, they darken the perimeter. It's blue because we made a closed loop path. So that's a valid closed loop path. You can get out of it. I always like to rename a sketch. What is it? Shallow pocket. And it is a kludge. I haven't found a way. I saw a Tormach uses them. Sprute Cam. They actually let you grab the toolpaths and drag them a little. That's pretty cool. And this program does let you edit toolpaths. There might have been a way to do that, and it turns red when you start editing toolpaths. I just hate doing that. I'd rather have, features and sketches and that driving the tools. Shallow, if I could spell, I'd be better off, wouldn't I? Shallow pocket kludge. Bang, done. And then last thing, I hide it because there's no need to clutter up stuff. So now let's see if we can pull this off. This is why I thought we'd risk going a little long. Do a file save. Yeah, we know. You guys are cool. No problem. See, it wants to change stuff. Now when you let SolidWorks CAM does this, it does automatic feature recognition. And all the holes that you change from giant 3/4 inch holes to a milled hole, they show up again and drills come back. So I've been saying, no, this won't affect any toolpath. All you did is draw a sketch. But this is how everybody, you change the model, it automatically changes. No, probably not. We'll play with that next round, not next episode, the next round of CAM evaluations. I don't know that we'll be able to pull this off though, because maybe there is a way. Open this up. Geometry. Reselect. Watch this. Instead of face 1, we're going to go here and say shallow pocket kludge. Shallow pocket kludge, that's the sketch name. Looks like it redid it, but then it didn't do any of the step overs or any of that business. It's doing too deep. Oh, no. Oh, I'm sorry, I had the don't show anything. Can't do that. It's still got the goofy problem of this point getting over the edge and doing a gouge here. I wish I could figure out what I did. See, now this is strange. Oh, maybe we didn't recompute toolpaths. Compute all tools. There we go. Now I'm loving it. Okay, that is why they're different. Because of these holes, see now, and I think it might leave an island there, but now we can go to shallow pocket. Oh, this is good. I'm glad we went through this. Edit. patterns. I know it might be hard to follow when I start whipping through this, but compute, didn't do anything different. Edit, patterns, 6, number of, maybe it's smart enough to know, and it says, okay, that's wide enough. Doesn't look it, does it? That's why we got to go. We're already at 35 minutes. I'm sorry. File save. We all know to do that before going anywhere. And then say here. Next stop, next stop, next stop, next stop. Do the find and then do the run. Oh no, it's still doing, I didn't do the finish on the deep pocket. It's machining error. I'm pretty sure, right? It's not machining anything. We know, we've been here. Edit, feature, 0. So yeah, see, it thinks it's, once again, it defaulted to going to the top. Pick the top. The top is, you start the shallow pocket here. Say yes. Pick the bottom. Any kind of quick, oh, I'll just redefine the geometry. Nothing works. Come on. 125. Now we got to go through all the other nonsense. No, that's parameters. Where it at? Where do they come up with their naming? Let's call this a parameter. Let's call that a pattern. I guess it makes sense in a software mind. I guess this is okay. Compute. That's what we want to see. That's what we want to see. And you see how it's done the toolpath straight across here, so the top part, and it's done the toolpath straight across here. And when it does the finish pass with no stock allowance, leaving a little meat on the sides that the rough pass does, when it does this finish pass, it can go through and get this little pocket because it's 26. Dave is a genius. He didn't make these diameters of all these fillets 2.5. That means the tool has to stop at that point in space and then change direction. He made them 0.26 diameter. So a 0.25 quarter-inch end mill will actually go and sweep around a little arc like this. Is that an arc? Ah, 2 little arcs. How cool. And then you see the same thing here in the finish pass. See how that's a little arc? Took a lot of doing in VisualMill. Advanced cutting parameters. It's like, no, don't make a straight line segment and make this inaccurate. Put an arc there. I want G-codes can do arcs. So, file. Sorry to be clumsy at the end here. If you're sticking with me, thank you. Bang. Next stop. Next stop. Deep. Oh, I don't know why it goes up there. Then the finish. Now it should be doing. It didn't crash, so that. Visibility. Turn off the toolpaths. See, and here's some of those, what's going on there? Because especially when you're used to that compare function in the other programs, it shows you red. Red means it's gouged, blue means it's excess material. But when I got through, like I said, last night was the first time I got all the way through the part, doing the holes from the bottom, decking the bottom off. And this verification report came out great. It showed that the 4 holes were a little oversized from what we understand. Tapping makes them look oversized. It's not really. Show excesses. The hole, you expect that. This hole, you expect that. There's stock left. But at least within this wide 8 thousandths, I wonder, view, all this stuff, viewport, start. You see, you can capture video. It's like, oh, this is pretty cool. I'm pretty sure. Oh, here it is, right up front, info. I'm sorry, I must have gone right by it. Collision tolerance? No, that's a collision tolerance. That's 8 thousandths collision. It's still not telling me excess to what? Excess to 1,000th? I did find somewhere here where you can whack a verification here. Simulator option, measure grid, wider. I thought I whacked this all the way over, but maybe not. Customize, access, capture. I thought there was a place where I made this as accurate as you possibly can. And you got to love it because unlike SolidWorks, these are really well rendered radiuses and stuff. So whatever you paid for, you got a good deal, BobCAD. So let's close the simulator. Let's save the part. File. Save. Yes, we understand. Okay. So, you know, it's a little different, but not too crazy. Once again, because of the simulator, I'm not super keen on it. But it's kind of doing. I thought the wizards are clumsy and big stuff, but you get to learn it. It's only been a few days, and already I'm getting... Now, here's the problem. It's a few days. Every day I've been working on this for hours and hours. So now what happens when I'm using it in a real-world situation where I use it for a week, 2 days maybe, and then go a month, 2 months, 6 months before I need another machining thing because I'm doing prototype work? Will I remember all of these little tricks and things? I don't know. VisualMill was just right there. Everything was intuitive. I spent 2 hours on MasterCam last night. I couldn't get a single toolpath out of it. I'm going to call my buddy Dave, who made this part, who's a MasterCam guy, and say, just get me started. How do I change planes and, you know, the most basic things I couldn't figure out. Reading Google, reading help, watching videos, still couldn't get one toolpath, one good toolpath. I finally got a facing operation about an inch above the part. So BobCAD, not too bad if you can live with the simulator. It's making parts. It's one of the less expensive packages. They quoted me a 3D price and then knocked some money off of the published price because it's a deal. Everybody's got a deal, right? So you got to put the cost of the thing in perspective. So it's doing what it has to do. So I'm not, you know, against BobCAD by any means. I'm going to reserve judgment on all these packages till I'm done with all of them. I think I'm just going to stick to the ones that work in SolidWorks. After that grief of having 3 files and what file is what, I'm going to do all Gold Partner SolidWorks things. SolidCAM, VisualMill, MasterCam, this outfit. There's a couple. Some are specialized for like mold production. I won't look at those. But thanks for sticking with me. If you stuck around this far, we'll see you next time. We'll keep working on this part in BobCAD. Till then, catch you in a bit.